Howdy and welcome back. We're now going to continue our discussion with kind of what happens behind the scenes when a overloaded function is called. So calling an overloaded function. Overload resolution is the process by which the compiler determines which specific function is called from a set of overloaded functions. The compiler determines this by comparing the arguments against the parameters of each function in the set of overloaded functions. So if we go back here, could be considered our family of functions. What's going to happen is if, say, r equal was called with, let's say, 1 and 2, each argument would be compared to each of the parameters within this family of functions. And what we will see here is that the best match will be the function that is chosen. In this case, that with two parameters of type integers is going to be a best match for this function call. And the compiler will rightly ensure that the definition of r equal that is operating on two integer parameters is called, and not the r equal version of the function for the integer arrays or the standard library arrays. So there are a number of different kind of scenarios that can play out during this process. The compiler finds exactly one function whose parameters is or are a best match for the actual function argument. What I just showed you was a best match. In this case, we saw a function call made with two integer values that was matched precisely to a definition of essentially r equal that had two integer parameters. What if the parameters don't quite match? What if there's not a best match? The compiler will then check to see whether or not a match can be made through a promotion. For instance, if we were to call our r equals with two characters, both of these character values, or their types rather, can be promoted to an integer. So in this case, an implicit conversion exists to ensure that we can resolve this call. So that would be a match made through a promotion. So from a narrower type within the same family of types to a larger. A match using standard conversions is what the compiler would then consider next. If we have r equal with two integer parameters, and let's say we made a call to this function with r equal 3.14, 4.85. Notice in this case, there's not a best match, nor is there a match that could be made through promotion. And again, we're assuming that we also have within this the whole family. So all of these are currently available to us. I'm simply considering this one because this will be the match that can be made through standard conversions. If you recall, implicit conversions exist to essentially have the compiler coerce a double to an integer. In this case, when the compiler looks at the options for the overloaded functions, it will see that, okay, we do not have an r equal that takes two doubles as its parameter. However, we do have one with two parameters of an integer, and an implicit conversion from double to integer exist. So in this case, 3.14, 4.85 would both be coerced into integers, and this function would be called. Now consider the following outcomes. If there is no function with the parameters that are best match, exact match, or compatible with the arguments, the compiler will report that there was no match. For instance, let's assume that we have this family of functions available again to us, and a call is made to it with the arguments of both values of standard library vector of integer type. In this case, we have no way to convert a vector to a string. No implicit conversion exists for it. Likewise, there's no implicit conversion from vector to an integer of an array of integers. Neither is there a conversion to a single integer object. So in this case, the compiler will complain and it will output a nice error message, which will say, error, there is no matching function call to R equal when the parameters are of the vector type. Now let's consider kind of the other option of this. Let's assume that for some reason we had these functions here available to us as well. We had an R equal that took a argument of type integer followed by one of double, and then an additional R equal whose first parameter was double, second parameter was an integer. What we're going to see here is that if there is more than one function that matches, and amongst the matches there isn't a best match, the compiler will report an ambiguous call to us. For instance, let's call R equal with 2.2 and 3.13. And let's assume that only these are in our family of overloaded functions. In this case, what's going to happen? Well, we do have an implicit conversion of a double to an int. However, in this case, both of these are a good match because in either of them, one argument or the other has to be implicitly converted to the integer type. In this case, the call is going to be ambiguous and the compiler will report that to us. Here, the compiler's message is going to be error, call to R equal is ambiguous, and it will show the function that we attempted to call along with the arguments. So that was a kind of brief overview of function overloading and how overload resolution helps the compiler determine which function should be called in an overloaded scenario. We're now going to move into a brief discussion on overloading guidance to wrap up this lesson.